Okay, understand trigonometry in 10 minutes. So that's the purpose of this video, is to not have you completely master the topic of trigonometry, but just to understand the essence of what it is. Now, before I get started here, I just want to tell you very quickly, for those of you that are interested, where you would study trigonometry. So trigonometry is the study of angles and sides, etc. And you kind of start studying it basically pretty much in high school. So in high school as a freshman, generally you're taking Algebra 1, and then you go on to Geometry and Algebra 2, and then you're taking either Trigonometry, but typically for most people they're taking like a pre-calculus course. And trigonometry is built inside this course. You also get a slight introduction to it in geometry, but it's an extremely important and very practical math, as you're going to see here in this example problem that we're going to do. And I think that's the best way to kind of show you, to demonstrate what trigonometry is and to understand just the fundamentals of it. Now, of course, you know, there's a lot more to it, but if you understand what I'm going to tell you here, even if you've never taken trigonometry or just basic algebra, it will have a good, healthy understanding of, oh, okay, this is what this mathematics is about. Okay, so trigonometry helps us solve problems like the following. So here's my little sketch, and this is the ground, and let's suppose this is a very tall building, and you wanted to know the height of that building. Let's suppose you just, for some reason you gotta get the height of that building. Now, how could you go about doing that? Now, it'd be pretty difficult, right, for you to stand up here and drop a tape measure all the way down to the bottom. I mean, yeah, there are all kinds of different ways you could devise, maybe drop a rope all the way down there, then bring it to the ground and measure it out. So you could somehow wrangle your way to get the height of that building. But let's suppose you couldn't even get to the top of that building. Okay, let's suppose, well, what if I told you, yeah, find the height of that building, but you can't get to the top of it? In other words, then you're going to be like, well, okay, well, how do I do that? Well, then you're going to maybe try to estimate it. But with trigonometry, you can get the precise, exact height. And this is the kind of problem that trigonometry allows us to solve. So how do we do that? Well, I'm going to kind of show you the basics of what we would do here, and then I'm going to get into actual instruction here in a second. So with trigonometry, what allows us to do to solve this type of problem is the following. Let's say you were down here at the bottom of this building, and you said, okay, what I'm going to do is I'm going to measure. I'm going to go out a certain period. I'm going to say, let's say I'm going to go here, all right, and call that distance whatever you want. Let's call it, let's say we went out 300 feet. Okay, went out to 300 feet, and then from at that point, you determine the angle up to the top of the building as you see it with relation to the ground. Okay, so how could you do that? Well, there's basic instruments. You can get a protractor. If you remember what those things are, it's like a little ruler down here, or then it has like 0 degrees, 180 degrees, and you just kind of measure different angles, etc. You can kind of flip this thing upside down and dangle a string. There's all kinds of little ways and not terribly sophisticated ways to get a pretty good sense of what that angle is. Now, of course, there's other instruments that would give you the precise angle, but let's say even you kind of like eyeballed it out and you kind of did whatever, sketched out. Anyways, we're kind of getting off on a tangent here, but let's suppose you were able to determine that angle. Well, as long as you knew the distance from here to here, this distance away from the building, let's say it's 300 feet again, and you got this angle. Let's suppose in this example it's 15 degrees. You're seeing the top of the building up here from where you're at to the very bottom of the ground. You're seeing it at about 15 degrees above the ground, like so. With those two pieces of information, and of course trigonometry, you can determine the height of the building. So that should be pretty cool. I mean, that's a pretty big problem, right? To measure the height of the building without being able to go to the top of it. So for you just to have these two pieces of information and to be able to get the precise height of the building is very, very powerful. Okay. Now, not only can you get the height of the building, you could also get this distance as well. Let's suppose you wanted to string a wire or something for whatever reason from the top of the building down to where you are. You get the precise distance using trigonometry and another thing in mathematics called the Pythagorean theorem. Don't want to get too far ahead of myself, but it's not that difficult. Okay, once again, these big concepts, trigonometry, calculus, yeah, there's a lot to learn, and there is some complicated aspects to them, but the essence of what they are is not overly complex, and they're very beautiful in a lot of ways, because think about it. I mean, with some mathematics, you can solve this problem, and we're going to solve that right now, and it's not going to be that difficult. Okay, so let's go ahead and do that. So what we want to do is we want to break down our problem into a triangle. Okay, so let's suppose this is the ground. Let's say this is 300 feet, and this angle here, let's say, was 15 degrees, and this would be like the top of a building up here, the top of the building, and then this is obviously the ground level. Okay, now there's a couple things here. Let me write that a little bit better. There's a couple things here that we have to be aware of in trigonometry. So you could see how I kind of made my depiction of my scenario here using a triangle. Well, in trigonometry, we use triangles to kind of depict what's going on, but not any triangle. We have to specifically use a right triangle. Okay, now a right triangle we denote with this little symbol here. It's a little box in the corner of this right angle. Okay, so if you don't know what that means, a right angle is a triangle that has a 90-degree corner in it. Okay, and we denote that this way. We don't write 90 degrees. We put this little square symbol. Okay, so if you see a triangle like that, that means it's right. This is 90 degrees. What we study in trigonometry, or the mechanics of it, requires us to use right triangles. Now, there are other techniques that we use with non-right triangles, but that's more advanced. Okay, so the fundamentals of trigonometry are going to be based upon these right triangles. Okay, so kind of get rid of this. So we're looking for this distance here, right? We're looking for this distance, and I said to you that if I gave you the degrees and the distance away here, we can get this distance, and we can. So this is where we're going to learn about trigonometry. Okay, so let's just keep this in mind. This is our kind of representation of the problem, and now let's get into the core fundamental concepts of trigonometry. Okay, so trigonometry is based upon the following. Okay, we have an angle. All right, now we have, in a triangle, we can have three angles. We can have this angle here, this angle here, and let me draw it this way. We can have this angle here, this angle here, or this angle here. Of course, we know this is 90 degrees, but these are going to be other angles. Okay, now in this triangle, we also have sides. Okay, so we have this side, or this distance to this triangle, this side here, and this side here. So what we're going to have to do is we're going to have to give these sides and angles kind of names. Okay, now this angle right here in this particular corner, we're going to learn this these names here in a second. So let's start with this angle. Now, from relative to this angle, the side of the triangle that's far off, okay, away from it, this side here, we have a certain name to it. Then we have a name to the side of the angle that's right next to it. Okay, and then there's another name to the longest side of the triangle. Now, each triangle, no matter what you have, you can clearly see which side is the longest. That's this side. Okay, now this side here is the side of the triangle that's next to the angle. And then we have a side that's away from the angle. Okay, so let's talk about what these sides are, respective to this angle. So the first side is called the opposite side. So we're just going to put an O. Okay, this is the O, opposite of this angle, far away from it. Okay, now the side that's right next to it, Okay, there's a word for that. That's called adjacent. This is actually called the adjacent side. Okay, the adjacent side is the side of the triangle that is forming that angle. You follow? You see what I'm saying? This side here actually connects with that angle. It's forming it. That's called the adjacent side. Again, the side that's far off, okay, immediately opposite, is called the opposite side. And then the longest side of a triangle is called the hypotenuse, and that's just we represent that with an H. Okay, hypotenuse. Right, the longest side of a right triangle is called the hypotenuse. So now we have HONA. Okay, now this is where well, I always like to teach trigonometry. People go kind of crazy when I'm going to tell you this. Trigonometry is based upon this crazy phrase. Okay, it's called Sohcahtoa. Sohcahtoa. It sounds kind of crazy. I know it does, but trust me, you'll remember this forever. All right. Once you learn it, you'll be like, it'll be stuck in your brain. Sohcahtoa. And what does that mean? Okay. Well, in trigonometry, we have these functions, okay? And if you look on your calculator, if you have a scientific calculator, you'll see these buttons, okay? S-I-N, and it's not sin. I know it's spelled the same way. It's not like, you're going to church and you're committing a sin. Maybe you're committing a sin watching this video. Anyways, hopefully not. But no, this is pronounced sine, okay? The next one is C-O-S. This is pronounced cosine. All right, and this is just obviously the abbreviations. And then we have TAN, okay, that is the tangent. Okay, so we have sine, cosine, and tangent, and these are the main things, the main functions that are going to help us solve these problems. Now, you'll understand what these are here in a second. So let's talk about the sine, okay? So the sine is going to be, let me actually use this color here. The sine is defined as so. When we think of so, we think of the sine. So the sine is the sine of some angle is defined as OH, the OH, and that means the opposite over the hypotenuse, okay? So the sine of this particular angle here would be the measure of this side, the O, right here, right? So if I went to get my tape measure out or whatever, if I knew this distance and I divided it by this distance, I would have the sine, okay? Now, of course, we don't have those distances right now in this particular problem, but don't worry about that. Just follow what I'm saying. The sine of this angle, if I wanted to find the sine of this angle, I just divide the O divided by the H, or we can remember that by the phrase so, okay? The cosine of this angle, right? And you notice I'm just putting a generic angle here, but let's say we're talking about this one here, is defined by ka. Okay, that is the adjacent over the hypotenuse. So in this case, it would be this side. Here, let me get rid of these here. The adjacent is this side over this side. Okay, so if I divided this side divided by that side, I would have the adjacent. I would have the cosine of that angle. Now you could probably guess what the TOA is, right? The tangent, just take a guess, if you will, is TOA. What do you think that is? O divided by H, okay? Or the opposite over the adjacent. So let's take a triangle. I'm gonna come back here to this figure in a second. Let's just take a real basic triangle. Okay, let's say this angle here, I don't know it. This is a 3, 4, 5 right triangle. Okay, these are actual correct lengths to this particular right triangle. And here's an angle here, right? So let's think about so. Okay, this is sine. So right, cosine. Toa. This is tangent. Okay, so the sine of this angle here, whatever angle measure this is going to be equivalent to what? The opposite. Its opposite is what? This is the opposite. Whoops. This is the opposite. This is the adjacent to this angle, and this is the hypotenuse. Okay? So in this case, the sine of this angle here is the same number as what? The opposite over the hypotenuse. So that would be 3 over 5, 3/5. Okay. So if we do that, if we go in our calculator and take 3 divided by 5, we're going to get a decimal of 0.6. Okay. So if I knew this angle, this actual angle here, and I went into my calculator and I took the sine of this angle, okay, and I'm sorry I don't have this pre-worked out right now, but we'll see how this plays out in the next problem here, I would actually get 0.6, okay? So if I had this angle and I go into my calculator and I put sine of that actual angle, it would be the same as 0.6. So hopefully you're kind of getting a feel for this. All right, same thing here, cosine. All right, so the cosine of this angle here is going to be the same as what? The adjacent over the hypotenuse. The adjacent happens to be 4 and the hypotenuse happens to be 5. Okay, so just that decimal, 4 divided by 5, 4/5, is what? 0.8. Okay. Now you're saying to yourself, well, cosine, if I plug in, let's say, cosine of 37 degrees. Well, how do I actually find this number? Where do you do it? Well, here's how you get that value. You need a calculator, okay? You need a scientific calculator that has its functions. Now, you don't necessarily absolutely have to have a calculator. That's the smartest and best way to do it. There's also tables that us old guys, old folks, used to have to use way back in the day, where you would have to actually look things up as an actual book. Can you imagine that? In this day and age, you'd actually use your textbook. You'd flip over. Matter of fact, if you have a a trigonometry textbook, you probably don't even use it. But if you go to the very back of it, where the table of or the index is, you'll see the actual tables. So you can look up these values, but obviously the best way to do it is just to plug these values into your calculator. So if you go to cosine 37 and you hit enter, it'll spit out a decimal. Okay, so we can get these values, but we can also get these values by just comparing these sides. So these trigonometric functions are nothing more than ratios of any two sides of the right triangle. That's all it is. So in terms of this angle here, trigonometry is just basically comparing any two sides of a right triangle. It tells us information about an angle inside of that triangle. Okay, that's all it's going to do. But let's kind of pull the parts together here and see, with our problem, how this is going to work. Okay, so let me erase all this and get back to our problem. Okay, so let's think about this. Remember, I want to find the height of the building. How can I find the height of the building here? Well, let's see. The height of the building in this particular problem is this distance here, right? So really what I want is the O, okay? I want the O distance, correct? In this particular triangle, I like to know what the O distance is, because the O distance, so the opposite distance here, the length, if you will, is actually representing the height of the building. But I have, in terms of my information in my problem, I don't have the H, I have the A, okay? I have the distance of the A. So I want O, I want the O length, but I also have A and I have the angle. So we have to think to ourselves, which one of these trigonometric functions should I use, okay, or can I use? Now, you could start off with one and kind of one trigonometric function may be able to get you to your answer. You kind of using a longer route, but in this case, we don't really have too many options, okay? We have to use the trigonometric function that has O and A both in it. So which one is that? Okay, so uses the OH, Ka uses the AH, and the TOA uses the O and A. Okay, and that's what I need. So I'm going to need the tangent function here. I get to select. That's what's cool about trigonometry. You select which one you need. Okay, I can use the sine if I have the opposite in a hypotenuse. I use the cosine if I have the adjacent in a hypotenuse. And I'm going to use the tangent if I am looking for the opposite and the adjacent. In other words, if the O and the A are involved in my problem, use that. Cosine, if the A and the H are involved in my problem, use that. And sine, if the O and the H are involved in my problem, use that. So let's go ahead and use the tangent. So how does this work? So this is going to be the tangent of this angle. Now this angle actually is 15 degrees. So let's plug that in. The tangent of 15 degrees is the same value. Okay, now first of all, let's go and before I even do this, I know I'm kind of taking a few tangents, but this is important. Let's get our calculators out. And if you don't have a calculator and you're obviously on the internet, you can go just do a quick Google search for scientific calculator and you can find out this. Okay, just take the tan, T-A-N, plug in 15. So let me go ahead and do that on my calculator. We'll work together. So the tangent of 15 degrees is this decimal value of like 0.267 and it keeps going. Okay, but you get the idea. So I know what that is. So the tangent of 15 degrees is this number. Okay, my calculator tells me. Of course, if you had a table of values, you can actually look that up as well. But in this problem, okay, we have some other sides of this triangle that's going to tell us the same value as well. You'll see how this works here in a second. So the tangent of 15 degrees, okay, by definition is TOA, right? So the tangent is the same thing as the opposite over the adjacent of your right triangle's information. Okay, so the opposite I don't know. I don't know what this is. This is what I'm looking for. So I'm going to use a variable. Okay, I'm just going to say that's x. I don't know what that is. That's what I'm looking for. But I do know the adjacent side, right? The adjacent side is 300. Okay, so now I have a nice little equation. I have tangent of 15 degrees is equal to x over 300. And if I solve this equation for x, I'll get my answer. So some of you are probably saying, oh, how do you solve this equation? This is very complex. Very simple, okay? So remember again, tangent of 15 degrees is actually just a decimal, but I'm going to leave it like this, okay? So tangent of 15 degrees is the same as this decimal 0.267, etc., okay? Now, when we look at a problem like this in algebra, let me erase this. We always want to make a number that's compared to another fraction into another fraction. In other words, we're going to write this over 1, and now I have two equal fractions, one fraction equaling another fraction. So let me show you how you solve a problem like this. So let's take the fraction 1/2. So what's another fraction that's equal to 1/2? There's any number of them, right? 4/8, 5/10. Let's take the fraction 7 over 14, okay? So 7 over 14 is the same thing as a fraction 1/2. This is actually called a proportion. And the way we solve these, super easy. All you do is cross multiply. So we're going to multiply the diagonals, this times this. So 1 times 14, okay, let's write it this way. 1 times 14 is just 14. And that's going to be the same as if we multiply across this way, 2 times 7. So we can see 14 is equal to 2 times 7 or 14, okay? So when you have a proportion or two equal fractions, we can just simply cross multiply, okay? It's called the cross product. That just means cross multiply, and we can solve. Now let's see how this works. Okay, so let's suppose I have an equation. All right, let's get rid of that 7. Let's put x. I have one fraction equaling this other fraction over here, but I don't know what this value is. Okay, well, let's cross multiply. 1 times 14 is 14. Okay, and 2 times x is 2x. So now I have this basic equation. Let's write it this way. 2x equals 14. And I can solve for x. You have to, of course, know some basic algebra to be able to do trigonometry. So if you're not we don't know exactly how to do this, all we're going to do is just divide both sides by 2, and we get x is equal to 7. And that's the value, right? This was 7. 7 over 14 is the same thing as 1/2. We're going to do the exact same thing here, okay? Recognize this tangent, 15 degrees, is the same thing as this decimal, and I can write any number over 1 when I want to create a fraction. In other words, 3 is the same thing as 3 over 1 as a fraction. If I want to look at 3 as a fraction, 3 over 1. If I want to think of 0.267 949 as a fraction, no problem. Just take that thing, put it over 1, and now I have 2 equal fractions because I know I can use this proportion to solve this. Okay, so let's go ahead and actually do this, and we'll wrap this up. So we're going to multiply across, right? We're going to multiply these two together, and then we're going to multiply these two together. All right, let's do this. 1 times x is simply just x. And then tangent of 15 times 300, we'll write it this way. Tangent of 15 degrees times 300. Of course, we know that the tangent of 15 degrees is the same as this decimal. 0.267 949, etc. You don't want to use in your calculator the full amount. We're going to multiply that by 300. Okay, so let's go ahead and do that now. And you can use whatever available device you have. If you have a calculator, that'd be great. Or you can use your online calculator. Of course, you don't want to do this by hand. You could just follow what I'm doing. But the answer roughly when we do this multiplication is going to be somewhere around 80.384. Okay, and that's our answer, okay? X, remember, when we set up this fraction, is the same as the opposite. So that means our building over here, or whatever distances this is, was 80.34 feet. 80.34 feet high. And that's it. Okay, now of course, I gave you the explanation, but if you're able to get the degrees here and get this measurement, and this you can get very precise, right? You can measure, you can walk this out, you can do all kinds of ways, and you can get the measurement of angles very precise as well. And here we have the exact precise distance of this side of this right triangle. And it's very easy from this point to get the distance from here to here. So this is the fundamentals of trigonometry. Everything is built upon this right triangle trigonometry. In trigonometry, the applications are just amazing. Okay, in a former life, before I taught mathematics, I was in the military. I was in the Marine Corps. I was also a Navy officer. And one of my tours as a Navy officer, I served as a navigator. So I used to navigate ships. I used to have to really understand celestial navigation, which is navigating by the stars. A lot of that is based upon what we're talking about here. On my YouTube channel and one of my video playlists, I have a video on celestial navigation that kind of explains this very straightforward. And after you watching this video, you'll really appreciate that video. But the power of trigonometry is tremendous, and again, like anything super complex, you can kind of distill it down to its fundamentals. If you understand that, it opens up new doors for you. Okay, well, listen, clearly this is a big topic to be studied in depth, but this is trigonometry in a nutshell. So I hope you enjoyed the video. Please subscribe to my channel, and if you're interested, I'm going to leave a link to my math learning website in the description of this video as well. Have a great day.